Hello YouTube, welcome to my channel. I'm Jaspreet Kaur and I work as a software engineer. This is the first data structure and algorithm series by me. Before we begin with the video, I would just like to let you know that you all should watch this video. It's basically for all the students who are currently studying computer science, for everybody who are preparing for interviews, who are preparing for placements, all the students who are learning programming by themselves. Knowing data structures and algorithm can be really helpful in improving your coding skills. Without any further ado, let's get started with the video. Before that, don't forget to hit the like button if you happen to like this video. So let's get started.
Let's see what all topics we'll cover in this video. First is what is data structure. We'll see what is an algorithm. We'll understand the time and space complexities, arrays, and then in the end we'll do one example question of an array. First, what is a data structure? So if you Google it, the definition you'll get is a data structure is a way of storing data in a computer so that it can be used effectively. In short, example, I gave you 10 numbers. So how you store these 10 numbers in computer's memory in such a way that it should be easy to do any operation. If I ask you that give me the smallest number out of these 10 numbers, or you sort the numbers, anything. So the organization of data is data structures. The example of data structures are lists, arrays, stacks, etc. We'll cover all this in the coming videos. First, understand the classification of data structures. Data structures are classified broadly into two types, which is a simple data structure and a compound data structure. So a simple data structure can be constructed with a primitive type. We have arrays, variables, pointers. These all come under the category of simple data structures. Second one is compound data structures. So these are the data structures which are also made with one of the primitive data structures, but it has also one specific functionality. These are again of two types, linear and non-linear. Linear data structure are the ones made as continuous arrangement of data elements in the memory. There is a relationship of adjacency. For example, you have stack, list. So these are adjacent. If variable of this data structure is stored at location 0, next one will be at 1. The next to next it will be at 2. So this is what makes them linear. Let's understand what's non-linear. This data structure is a collection of randomly distributed data. It can be kept at any memory location. Let's say the first element is there on location 200 of your memory. The other one can be at location 206, at location 207. Next thing is what's an algorithm. An algorithm is a step-by-step procedure. The steps we have to tell the computer to perform to give us a certain output has to be very descriptive. Now let's take this example of how to code the program to add two numbers. So the first step will be start add. Here start add. Now get values of a and b. We have two variables a and b. Now to add numbers, add two numbers, you need to know what are those two numbers. So we will add a and b, and then this left arrow. This left arrow shows that we are substituting, we are putting the sum of these numbers in C, and then we have to display C, which is output of the program, and the step 5 is to stop. So that's how we write an algorithm. There are two very much important concepts when you study DSAs, that's time complexity and space complexity. And this is important because whenever you'll go to any interview, first the interviewer will give you a problem statement, a problem question, and then once you give him the solution, he'll definitely ask you what's the time and space complexity of your code. Time complexity means that how much time your computer needs to complete the program. Space complexity, it means what space, how much memory you will use, how much memory your code, your program is going to use till it finishes. There are various methods of finding the time complexity. We will be using frequency count. Here you can see the program statement that I've given, and the statement says x is equal to x plus 2, and here is the frequency count. The frequency count is 1. Why? Because it's one single line and it will be executed only once. So the frequency count is 1. So what do we get the total frequency count as 1? So the time complexity of this program is big O1. There are different notations for a time complexity. We have big O, we have theta and other, but mostly we use big O. Let's take another example. Here you can see we have a for loop which runs from k is equal to 1 to n. And what are we performing in the for loop? X is equal to x plus 2. Now let's see. The loop is from 1 to n. When the value of k will be n plus 1, at that time for condition will be false and will come out of the loop. So this line of code will run n plus 1 times. Now let's go inside. This thing will run n times because the for loop will become true n times and the end statement will also run n times. So the total frequency count which we'll get after adding these three is 3n plus 1. Time complexity will be big O(n). Now we'll understand what is an array. Array is basically a collection of similar type of data. Whatever data you're storing in an array, it has to be of same type, which will be stored at contiguous memory location. By contiguous memory location, we mean adjacent to each other. Let's suppose you are standing on this staircase, the third staircase. So if you were to define your location, okay, in terms of the steps, where do you stand? So you will say that you are standing on the third step. Similarly, come to this array. If I ask you where is number 63, so the 63 number is stored at index 2. So index 2 defines where number 63 is stored in the array. Now we'll do an example question.
Write a function rotate that rotates array of size n by d elements.
So before I give you guys a solution, I want you all to pause the video over here, find your own solution, and you can compare with what we discussed in the video. And also, if you understood what I'm teaching, make sure you like the video and you subscribe to the channel, as this will help me to make more videos for you guys. Here's the question. I took the question from Geeks for Geeks. This is the website which I would recommend all of you for your preparation. So first let's understand what do we mean by rotation of an array. Let's suppose this is the given array which has the following numbers. Now I ask you to rotate the above array by 2 elements. Take first 2 elements and this is from where you have to rotate your array. After the rotation, 3 will come in the front, 4, 5, 6, 7 and 1 and 2 went to the last. So this is how the rotation happens. Let's understand the first solution. The first method we'll do is using a temp array. So let's see the algorithm. We have an array which has elements 1, 2, 3, 4, 5, 6, 7. Okay, d is equal to 2. So go to the question. We know d is the number of elements by which we have to rotate the array and n is size of array. So how many elements this array has? 7. So the size of this array is 7. Now what we will do is we'll store the number of elements by which we have to rotate the array in a temporary variable. So we took this temp array and the first 2 elements, as we had to rotate the array by 2, like first 2 elements, so we kept the first 2 elements in temporary array. Now what we will do is we'll shift the rest of the array. Okay. From this temp array we'll store the last 2 elements back to the place at the end. Now the time complexity of this array is big O(n). How big O(n)? While shifting the array, we will be traversing the entire array. So whatever is the number of elements, let's say there are 10 elements in the array, so you will loop through all the 10 elements. The time complexity will be big O of 10. N will always be the size of the array, so the time complexity became big O(n). And now d, big O d is the space complexity, the auxiliary space. Why? Because we'll need some memory to store these. Okay, we are taking these from this array and we are storing in a temporary array, so this is occupying extra space. let's see another method. Okay, so what we can do is we can rotate the numbers one by one. So let's understand the solution through code. We'll start with the main function. So here we are using a rotate array class. So here is the definition of this rotate array class. Okay, come down. So array is of type int. We have 1 2 3 4 5 6 7, and now we are calling the rotate array class. We are sending the array. 2 is the number of elements by which we have to rotate it, and 7 is size of array. So now let's see how this class will work. We'll see over here. This is the same piece of code. So here, this is your array. Okay, so your D currently is 2, N is 7. This loop works for I is equal to 0, I less than 2, I less than D, which over here is 2. It means this loop will work 2 times, for 0 and for 1. Okay, so now we call the left rotate by 1. So this function will rotate the entire array by one element at a time. So we are passing the array, and n is again size. Okay, so here we have taken the temporary variable. So we are putting in temp the value 1, array of 0, right? Array of 0 contains 1. See, here is your array. We'll keep this over there. Okay, let me just write it over here. So this is your array. Okay, so now temp contains the value 1. This for loop will run for I is equal to 0, I less than n minus 1. So n is 7. This means this loop will run 6 times. So when I is equal to 0, at array of 0, we are substituting the first value. So when this line runs, what will happen is, array of I, which is 0 right now, here you will get I plus 1, that is 2, right? And in temp we have 1. Now now again we'll come over here. I will get incremented by 1. I is less than n minus 1, yes. 1 is less than 6. So what will happen? Array of I means an array of 1, we are keeping 1 plus 1. So after second round, this will come. So when this loop will run, this substitution will happen. Okay. Now when I is less than n minus 1, 6. So when it's 6, the condition will become false and it will come out. So at array of I, we are substituting temp. So what we had in temp was 1. Now when this comes out of this loop, the value of I is 6. So where is 0, 1, 2, 3, 4, 5, 6. This is array of 6. So we are again substituting this with 1. So this was the first round of rotation. Okay. Now again come back to this for loop. I will get incremented. I will become 1. Okay. So this runs till I is less than 2. Again we'll pass the same array. The same procedure will happen over here. Okay. At array of 0, now we have 2. This 2 will get substituted by 3. Similarly, this will get substituted by 4. This one by 5. This one 6. 7. Here we'll get 1. Okay. Now this time when it comes, in temp we have array of 0, which is 2. So when it comes out of this loop, array of I, when it will come out of this loop, the value of I will be 6. And at 6th position, now we are substituting it with this temp array where we store 2 first. So here we'll get 2. And we are calling this function to print the array one by one. Here it is. So your rotation of array is complete, and this was the second method. Okay. Now the time complexity becomes n star d. How n star d? N because this loop will run n times into d, because this loop will call the second loop d times. So this will be the time taken. Okay. But in this case, we have decreased the space complexity. Space complexity became big O of n. And how it became 1? Because this time we are using only one temp variable, where we will be using one element at a time to rotate.